What's up, guys? Hope you guys are doing well. So we're out here on a hike, and whenever you're going hiking, you gotta come prepared, but you also have to match your own personality. For example, I'm wearing shoes. Mr. Brost, he's wearing flip-flops.
Yeah.
And who's most prepared? Mr. Richter, who's wearing boots.
Hey, social distancing! This video isn't going viral, literally!
Okay, so today is 11.3. We're still looking at volume, and I'm going to add the surface area. So we're still looking at volume and surface area of cones and pyramids today. So previously we looked at our cylinders and prisms. Today we're looking at cones and pyramids. So remember what a cone looks like. This would be our cone. Sorry about the terrible drawing. And we're also looking at our pyramids. So cones and pyramids, that's what we're looking at today. Now remember, the surface area is the area on all of the surface. So if I were to add up all these individual surfaces, the areas on each of them, add them all together, it gives me the total surface area. Now, the lateral surface area is the area going around the shape, excluding the base. So the lateral area for my pyramid is the area going around the shape, excluding the base. So typically what we'll do is calculate the lateral area. We'll do that first, and then we'll just add it to the area of the base. And that'll give us the total surface area, the area in all the surfaces. Now the volume, again, is just the amount of space inside our three-dimensional shape. So that's what we're looking at today, is how to calculate the lateral area first, then we'll look at the surface area, and then the volume lastly. Quick reminder, capital B stands for the area of the base, capital P stands for the perimeter, and then we'll use, obviously, C for circumference, and then H stands for height, R for radius, and now we also have this italicized L. Now this L here, that's going to stand for the slant height. Now what is the slant height of a shape? Well, the slant height is, just a second, this part here. It's the side of your shape. So right here, if I were to draw a dotted line starting at the apex here, going down to this side, it's perpendicular to that base, but it's on the actual, it's on the surface. That's a terrible arrow. It's actually on the surface of your pyramid in this case. So if I were looking at the slant height over here, let me erase this. So my slant height on this side, which this would work, the slant height over here would be on the actual surface coming down to the base, but it's perpendicular to the base, and that's what we would call L, the slant height. Now quick spoiler of what we're going to be using that for is, let's say we have a cone and I have the slant height, I have the radius, but I don't know what the actual height of the cone is. So I don't know the height. Well, hopefully you guys see it. What we can do is get a right triangle here. We'll use the slant height, the radius, or maybe we're just using half the base in this case. We use, if this is the length of the base, we just cut in half to create a right triangle. So what we can do is to calculate the height of our shape, we just use the Pythagorean theorem, where we'd have r squared plus h squared equals the hypotenuse L squared. Now again over here, I just use half the base here. That corresponds to half the side length. And if I want to solve for the height of the pyramid, I use the slant height. So I'd use half of r, or sorry, not half of r. Let's say this is side length s. So I just use half of the entire side length here. Square that, plus, if I don't know what the height is, just use h squared is equal to the slant height squared. So that's why the slant height is useful. And again, the slant height is just this portion on the side here, on the surface of the cone or the pyramid. So there is our different variables, what they mean. All right, let's first look at a pyramid. And we're going to be dealing mainly with right pyramids and right and regular pyramids. So right, regular pyramid. So we have a regular base, equiangular, equilateral. So to do this, to calculate the lateral area, again that's the area going around the shape. To calculate the lateral area, what I'm going to do is take capital L, that's equal to 1/2 the perimeter of the base, capital P, times L, the slant height. So you're going to calculate the perimeter of your base, and then you're going to multiply it to the slant height, and then divide by 2, and that will give you the total lateral surface area. Now again, if I wanted to calculate, because notice in this diagram here I don't have the height, which is right there. So since I don't have, or you can look at this is a better picture, I don't have the height. So to do this, the best way, what I just previously said in the last slide, is that we'll use half the base, or half the side length of the base. I'm going to say S for side length. So I'm going to use half of that length, square it because I'm creating a right triangle, plus H squared is equal to the slant height here, L squared. And that will allow me to solve for H. Now, how do I calculate? This is for a right pyramid with a regular base. That's where I can use all of this. Now, what happens if I don't have a regular right pyramid? What I can do is just calculate each of these surfaces individually. So I calculate this triangle, I calculate this triangle, calculate this backside triangle, and this side over here, that triangle, and just add them all up. So all we're going to say is that I'm going to say for other pyramids, we're just going to add the areas of the individual faces lateral faces. So we add those up, that'll give us the total lateral surface area. Now how do I calculate the total surface area? So my formula here to calculate the total surface area, so the total area of every single surface, including the base, well, all we're going to do is say that S surface area is equal to the lateral area, lateral surface area, plus the area of the base. So I calculate the lateral surface area, add it to the area of the base, and I get the total surface area. Now what about the volume? What's the total units, total amount of space inside the three-dimensional shape? Well, the volume is equal to 1/3 capital B, which is area of the base, times the height. So this is my formula to calculate the total volume of your pyramid. Let's go and look at a cone. How do I calculate the lateral area of my cone? Let's start with that. So to calculate the lateral area of my cone, this is h, that's the height of my cone. What we're going to do is first say that L, lateral area, that's going to be equal to pi times the radius times L, the slant height. So pi times radius times the slant height. Now the reason we get this, you don't have to write this down, but we'll just do a quick explanation. Notice on the pyramid it was 1/2 perimeter of the base times the slant height. Well, since we're dealing with a circle, instead of using P for perimeter, we use L or C for circumference. Well, if I do that, then the circumference is 1/2. To find the circumference of a circle, it's 2 pi r times L, where notice that the halves cancel each other out, and I'm left with pi times radius times L. So that's a quick explanation of how we get that. Now, just like the pyramid, I still have a right triangle here, so I could use radius squared plus the height squared equals lateral, or the slant height squared, using Pythagorean theorem. So I can still use this to solve for the height or the slant height if I need to. So don't forget about the Pythagorean theorem here. Now the surface area, the total surface, or total area on all the surfaces, that's just going to be equal to the lateral area plus the area of the base. Now again, we have a circle, so to calculate the area of the base, pi times radius squared. Now let's look at the volume. The volume is equal to 1/3 area of the base times the height. So same thing as our pyramid. If I were to substitute my equation for area of the base, pi radius squared times the height. But if you remember this, you're good to go. So just like we did previously, you're going to still start with the area of the base, and then you're just going to multiply it by the height of your cone, but divide by 3 now. So that's all you got to do. Let's do a few examples. Let's start with this pyramid here. What's the lateral area of my pyramid? So to calculate the lateral area of this pyramid, well, first notice that it is a right regular pyramid. So I'm going to be using the formula L is equal to 1/2 perimeter of the base times the slant height. Let's go and calculate the perimeter of the base. That's going to be equal to, I have a square, 30 by 30 square. So if I add up all the sides, I get 4 times 30. Perimeter of the base is 120 feet. And while we're at it, let's go and calculate the area of the base. Since it's a square, I'm just going to use s squared. That's going to be equal to 900 feet squared. So I get 120 and 900 for the area of the base. So I substitute, I get 1/2 times 120. Now the slant height, what's my slant height here? Well, to do this, I'm going to set up my right triangle. Well, my height is 8. But what's this side right here? Well, if my full side length, this full side length is 30, I need half of it. I'm just going to do 30 divided by 2, and I get 15. And that will give me the slant height. So I get 8 squared plus 15 squared is equal to the hypotenuse L squared, which then gives me L is equal to 17 feet, using the Pythagorean theorem. So I get 17 feet here. So my lateral area, when you do your algebra, you get 1,020 feet squared. Let me double check myself really quick. Yeah. Now let's calculate the surface area. Well, surface area is equal to the lateral area plus the area of the base. And the lateral surface area is 1020 plus 900, which is the area of the base. I get a surface area, which is equal to 1920 feet squared. Don't forget units squared for area. So again, take the lateral area, take the lateral surface area, add it to the base, and get the total surface area. Now let's look at volume. The volume is equal to 1/3 area of the base times the height, 1/3 of 900 times the height, which is 8. And this gives me 900 divided by 3 times 8 gives me 2,400 feet cubed. And that's my volume. And don't forget, for volume, you have feet cubed, units cubed, power of 3. So that's your total of volume for your pyramid here. Now let's go ahead and look at a cone. How do I solve for the lateral area, lateral surface area of my cone? Well, the lateral surface area for the cone, and notice that this is a right cone. I get 1/2, sorry. So for my cone, the lateral area is equal to pi times the radius times the slant height. So pi, my radius is 6. The slant height is 10. So 10 times 6 gives me 60 pi, and I'm dealing with centimeters, so centimeters squared. Again, if the question asks you to keep it in pi, keep your answer in terms of pi, make sure you keep pi as part of your solution. If it says round to the nearest 10th hundredth, make sure you multiply by pi and then round. If it doesn't say anything, you're free to do what you want. Let's go and calculate the surface area now. The surface area is equal to the lateral area plus the area of the base. Well, what is the area of the base? So to calculate the area of the base, that's pi times radius squared, pi times 6 squared. It gives me 36 pi centimeters squared. That's the area of the base. So I get 60 pi plus 36 pi. So I get a total surface area of 96 pi centimeters squared. Now let's look at the volume. The volume is equal to 1/3 area of the base times the height. So we get 1/3 of 36 pi times the height, which is what? Just like we previously looked at, I have a right triangle here. So to calculate the height, my base is 6. because that's the radius. I don't know what h is. The hypotenuse is 10, so I get h squared plus 6 squared is equal to 10 squared. And then after you do your algebra here, you get the height is equal to 8. So the height is 8 centimeters. So this, when you multiply it together, you get, let me see, yeah, 96 pi centimeters cubed as your volume. Let me double check myself really quick. Okay, we're good. And notice that your surface area and the volume are the same, which is kind of interesting. 96 and 96 pi. 96 pi, 96 pi. But notice the difference here is that this is centimeters squared for surface area, and this is centimeters cubed for volume. Again, if you mess up the units, obviously you're going to be docked a couple, maybe half a point or something. So that's how you calculate the surface area and volume for a cone and a pyramid. But let's look at this one. Here's our composite figure. Remember, that's like a combination of two different shapes. But on this diagram here, what we have is we have a rectangular prism. But notice, hopefully you can tell from the picture that there's a pyramid here that's going inwards. So it's like this inner part here, it's almost scooped out, and you have that pyramid that is going into your rectangular prism. So how do I calculate the volume of this, of this shape here, if this center part here, if that's scooped out, if it's taken out? How do we do that? Well, first, let's calculate, and we're just looking at for the volume. Let's calculate the volume of the rectangular prism. So calculate the volume of your rectangular prism here, and calculate the area of the base, and multiply it by the height. Well, the area of the base is 25 times 12. And the height is 15. So that gives you, let's see, 25 times 12 times 15. That gives you 4,500 feet cubed for the volume of the rectangular prism. Now we need to calculate the volume of this pyramid here. That pyramid was being scooped out. So how do I calculate that volume? I'm just going to draw a quick sketch over here. It's not going to be great, as usual. Just give you an idea. Well, what's this side here? So what's this side if I just flip it over? Well, if this base here is 25, obviously this is still 25. This side here, same as that, so I get 12. And what's the height? Well, if I take this section, just move it over here, I get 15 for the height. So, what we're going to do now is calculate the volume of the, I'm just going to say P for pyramid. Volume of the pyramid is going to be equal to 1/3 area of the base times the height. So we get 1/3. Well, what's the area of this base? It's 25 times 12, and the height is 15. So really, all we're going to do is take this and divide by 3. And that gives me the volume of the pyramid is 1,500 feet cubed. Now that's not my answer, because what we're doing is scooping out the center part, right? So how do I scoop this out mathematically? So my total volume is going to be equal to 4,500 minus the volume of the pyramid, which gives me 4,500. I shouldn't be able to. 3,000 feet cubed, and that is the final answer, volume of the total shape. Alright, so if you guys do have any questions, make sure you send me an email. Make sure if you want some extra video chat help, let me know. We can work that out. You guys do have a quiz this Thursday starting at 10 a.m. on the first part of chapter 11. Tomorrow what we're going to be doing is just going over different problems from the homework and stuff that you might be seeing on the test. I'm just going to give you more, it's just going to be a review day. I'm just going to go over different problems for review. So I hope you guys have a good day. Let me know if you need any extra help. Alright, see ya.